We have reached a hard limit in our understanding of the universe. For a century, physics has been divided by a massive schism. General relativity perfectly predicts the behavior of the massive macro-universe, stars, planets, and galaxies. Quantum mechanics flawlessly describes the microscopic world of atoms and subatomic particles. But if you try to combine their mathematics to explain how the entire universe works together, the equations break down, collapsing into infinite errors in a problem physicists call renormalization. Compounding this mathematical failure is a glaring observational anomaly. Everything we can see, touch, and measure, every star, planet, and speck of dust, makes up just 5% of the cosmos. The remaining 95% consists entirely of unseen phenomena we classify as dark matter and dark energy. We know these massive, invisible forces exist because we observe their gravitational effects on galaxies, but our instruments cannot detect the actual matter or energy producing those forces. Our current models of reality cannot account for the vast majority of the universe. The math breaking down at the quantum level and the missing 95% of cosmic mass are not separate problems. They are the exact same problem. They prove we are missing the unifying foundational physical fabric that connects the micro to the macro. Quantum Soft Foam Wormhole Theory, or QSFWT, provides that exact unifying framework. To see it, we have to scale all the way down to the absolute smallest measurable unit of reality, the Planck length. Down here, the vacuum of space is entirely devoid of traditional matter, but it is not empty. It is filled with quantum soft foam. This is a dynamic, fluctuating scalar field that acts as the actual physical fabric of spacetime. It exists everywhere, constantly interacting with surrounding matter and gravitational curvature. As this foam rapidly fluctuates, it generates highly unstable, temporary distortions in the literal geometry of spacetime. These distortions manifest as micro-wormholes, snapping in and out of existence, creating microscopic bridges between different coordinates in space. This boiling foam of ephemeral micro-wormholes operates continuously in the background, acting as the active, hidden engine that drives all physical phenomena we observe in the macroscopic universe. We can observe the effects of this foam by looking at quantum nonlocality. This is the phenomenon where two entangled particles appear to communicate instantly across vast distances, seemingly violating the speed of light. QSFWT resolves this apparent paradox through a mechanism called quantum tunnel hopping. Instead of traveling linearly across empty space, particles utilize the temporary micro-wormholes generated by the foam to instantaneously hop from one coordinate to another. This bypasses linear space entirely while perfectly preserving physical conservation laws, like the Heisenberg uncertainty principle. This chart plots the probability curve of that behavior. As the time intervals between hops increase from 10 to the negative 22 seconds up to 10 to the negative 10 seconds, the probability of a particle utilizing tunnel hopping surges from just 1% to 99.99%. Once past that threshold, tunnel hopping becomes the absolute dominant behavior of the particle. Quantum entanglement requires no mysterious, spooky action at a distance. Particles are simply navigating a shared physical network of microscopic wormholes. Scaling out from individual particles to the galactic level, the exact same mechanics explain our missing mass problem, dark matter. In the early universe's extreme conditions, intense quantum foam fluctuations clustered and compressed together, stabilizing into literal micro-black holes. These micro-black holes have an incredibly specific mass range, existing strictly between 10 to the negative 15th and 10 to the negative 10th solar masses. This pie chart breaks down the composition of dark matter based on those metrics. It reveals that micro-black holes weighing exactly 10 to the negative 12 solar masses account for an overwhelming 80% of all dark matter density in the known universe. Dark matter requires no undiscovered exotic particles. It is the direct gravitational artifact of quantum soft foam fluctuations compressed into microscopic gravity wells. Scaling all the way out to the macroscopic cosmic web gives us the mechanics behind dark energy, the negative pressure driving the accelerating expansion of the universe. Massive cosmic events, specifically the merging of supermassive black holes and the dynamics of macroscopic wormholes, generate intense, instantaneous electromagnetic fields across space. When these intense electromagnetic fields interact with the surrounding quantum soft foam, they generate a net negative pressure that actively pushes physical space apart. When you calculate the negative pressure generated by this interaction, it aligns perfectly with the observed 68.3% energy density of dark energy currently measured by cosmologists. This is an empirical model, and it provides specific, testable predictions. QSFWT predicts highly specific gravitational wave signatures that differentiate it entirely from the standard predictions of general relativity. Future observatories will hunt for these exact frequencies: high-frequency quantum foam echoes occurring between 100 Hz and 10 kHz, and lower-frequency wormhole ring-down signatures between 10 and 100 Hz. From the microscopic teleportation of a single subatomic particle to the accelerating expansion of the entire cosmos, a singular mechanism, quantum soft foam, explains the structural behavior of reality. Understanding this structure moves us from cosmological observation into advanced engineering. If spacetime is a foam, it is no longer a passive backdrop. It is a manipulatable medium. That manipulation relies on the core engineering concept of temporal resonance frequency, or TRF. TRF is the precise frequency at which quantum fluctuations naturally synchronize and resonate with the temporal distortions occurring inside the foam. This line chart shows exactly how that resonance behaves. As the temporal resonance frequency increases along the bottom axis, the rate of energy transfer between distant quantum systems certitude. This synchronization creates a state of coherence between the fluctuations at two separate locations. Because the foam acts as a bridge, energy can jump between these synchronized systems instantly, bypassing the linear space that normally separates them. Mastering TRF removes spacetime as an absolute barrier and transforms it into an active, high-bandwidth network for energy and information. This leads directly to the ultimate engineering application of QSFWT: faster-than-light travel. The theoretical roadblock to FTL has always been stability. Natural wormholes generated by the foam collapse in a tiny fraction of a second, roughly 10 to the negative 36th seconds. They cannot be traversed naturally. The solution is to apply precisely sequenced electromagnetic field pulses to the wormhole. These targeted pulses generate sustained negative pressure within the structure. This EMF-induced negative pressure props open the Einstein-Rosen bridge, stabilizing the wormhole throat for up to a full second. That is a massive expansion in time, long enough for an object to traverse it. This visual comparison illustrates the result of that stabilization. A traditional 10,000-year interstellar journey crossing 10 light-years of space is reduced by the stabilized wormhole to a trip of just 10 minutes. Quantum soft foam wormhole theory identifies the physical mechanism behind cosmic expansion and particle behavior. These equations demonstrate how to manipulate the energy density of the vacuum to reduce light-year distances to minutes, providing a practical path to the stars. To explore more unified theories and journey deeper into the fabric of reality, return to MDU and like and subscribe.